Hemodialysis machines are all a little bit different, but they have many similar components. We'll look at the major components of a hemodialysis machine in two categories: the blood circuit and the dialysate circuit. First, let's look at the blood circuit. The blood circuit for the hemodialysis machine is divided into the inflow, or arterial, bloodline, which carries blood from the vascular access in the patient to the machine, and the outflow, or venous, bloodline, which carries blood from the machine back to the vascular access in the patient. These two segments are divided by the dialyzer. Within the inflow bloodline, there is a blood pump dividing the inflow bloodline into the pre-pump and post-pump. Let's start by looking at the inflow bloodline pre-pump. Along this segment, there is a port through which you can collect blood samples, a saline line used to prime the dialyzer circuit and for rinse back at the end of dialysis, and an arterial pressure monitor which reads the negative pressure along this portion of this circuit. If the connection is broken along this portion, air can enter the bloodline. Bubbles of air can be trapped in the fibers of the dialyzer, leading to reduced dialysis efficiency and clotting of the circuit. If enough air gets into the circuit undetected, it can even enter the bloodstream, causing an air embolism. Usually the pressure monitor is configured to stop the blood pump if there is a disconnection and loss of negative pressure that exceeds the set limits. Typically, there will be alarms and visual warnings if this occurs. The blood pump is a spring-loaded roller pump that completely occludes the blood tubing and works like milking a straw along its length. The roller squeezes the tubing as it rolls over, then releases the tubing to allow refilling. The inflow bloodline post-pump is the segment between the blood pump and the dialyzer. This segment of the blood circuit contains a port for heparin infusion. Most patients need a bolus of heparin at the beginning of dialysis and/or throughout to keep the circuit running without clotting, though some people can be dialyzed without anticoagulation. In some hemodialysis machines, there might be a pressure monitor here as well. The outflow, or venous bloodline, is located after the dialyzer. There is a venous strip chamber, or air trap, that allows removal of any accumulated air from the line, a venous pressure monitor, and an air detector. The venous air trap and detector are very important for patient safety. The chamber traps any air that may have entered the bloodline before the blood is returned to the patient. Any detected increase in air triggers an alarm. If this happens, the hemodialysis machine will stop working. The inflow pressure valve is usually combined with the outflow, or venous pressure monitor, to estimate the average pressure in the system. During dialysis, pressure cutoff limits are set, so if there is a sudden rise in pressure due to an impending clot, or a sudden lowering in pressure due to a disconnection, the blood pump will turn off. Now let's focus on the dialysate circuit. In general, dialysis machines mix concentrated electrolyte solutions, or powders, with purified water to make the final dialysis solution, or dialysate, that will be delivered to the dialysis filter. Dialysis solutions must be delivered at the proper temperature of 35 to 38 degrees Celsius, and excess air must be removed from the solution before use. There are several monitors and alarms in the dialysate circuit for temperature and electrical conductivity. If the proportioning system excessively dilutes or concentrates the dialysis solution, it can lead to electrolyte disturbances and/or hemolysis. The concentration of the dialysis solution will be reflected by its electrical conductivity. If either the dialysis solution conductivity or temperature is found to be out of limits, a bypass valve is activated to divert the dialysis solution around the dialyzer directly to the drain and not to the patient. The blood leak detector is located in the dialysis solution outflow line. If this detector senses blood, as occurs when a leak develops through the dialyzer membrane, an alarm is activated.
So I hope you liked this video. Absolutely make sure to check out the course this video was taken from and to register for a free trial account which will give you access to selected chapters of the course. If you want to learn how MedMastery can help you become a great clinician, make sure to watch the About MedMastery video. So thanks for watching, and I hope to see you again soon.